Okay, what we're going to look at is what's called a statics problem. This is probably the most complicated vector problem that I will ask you to solve in pre-calculus. We're not going to go super crazy in the vectors. This is more like an introductory. So the type of problem I'm going to give you is, say we have two cables that are suspended from a roof. And attached to it is something that weighs 1,000 kilograms. I want to know what is the force or the tension on the first cable here and what is the force on the second cable. I'm going to tell you that this meets at 45 degrees and this is at 30 degrees. So what we need to know for statics is the idea that the sum of all of my forces in the x direction have to equal 0, and the sum of the forces in all the y direction also has to equal 0. That means it's being held in static or it's not moving at all. So what I need to do is actually need to set up a whole bunch of forces in the x direction, a whole bunch of forces in the y direction, make sure I get everything set up correctly, and then from there it's going to be a system of equations. I'm going to solve a system of equations. All right, so the first thing I'm going to do is, well, let's set up. Well, this 1,000 kilograms we know is getting pulled down by a force. So this vector right here, this is pretty easy. It's going 0 in the x direction and it's going negative 1,000 in the y direction. So there's one vector. You can just think about that vector. The other ones are here. We're going to break this down. I have a vector, an x component here, and I have a y vector here. I have an x vector here, and I have a y vector here. All right. I know that this is 45 degrees. I know this is 30 degrees because a parallel line is cut by a transversal from geometry. But when I set these vectors up, I want to make sure I use the correct angle so my signs are correct. So for force 2, well, let's do force 1. Force 1 is going to be, let's see, my vector for force 1 is going to be force 1 times cosine of 45 degrees sine of 45 degrees. So that's going to be, let's see, my force component is going to be f sub 1 square root of 2 over 2 comma square root of 2 over 2 f sub 1. There is my vector for broken in components right here. So here's my x component, here's my y component. All right, let's do the same thing here, but I'm not going to use 30 degrees. I'm actually going to use this angle here, which would be 180 minus 30, which would be 150 degrees. So what I'm going to do is I'm going to do force sub 2 times cosine of 150 degrees sine of 150 degrees. Well, it's still going to be my 30s, except now I just know my x has to be negative. So I'm going to have a let's see, a negative square root of 3 over 2 force 2 and a positive force sub 2 over 2. These are all from the unit circle and just multiplying it out. All right. Now that I've got this all squared away, let's add up all my x and my y vectors because I have 1, 2, 3 vectors I can add up. So the sum of my force in the x direction, the sum of my force in the x direction. So I'm going to look at all my x's. I have a 0 plus, well, I have this. So let's do that one first. Square root of 2 over 2 force 1 plus a negative square root of 3 over 2 force 2. Okay. And this has to equal 0. So we know that this is going to equal 0. We also know the sum in my y's are going to equal 0. So I'm going to add up all my y's. I've got a negative 1,000 plus, let's see, square root of 2 over 2 force 1 plus force 2 over 2. So we know these is coming from here. I have my system of equations. So what I'm going to do is I'm going to solve this by doing the substitution method. I'm going to ignore this plus 0 because you never write it. And this is actually fairly straightforward to go ahead and solve for. Let's say, I don't know, F1. So I'm going to say F sub 1 square root of 2 over 2 minus the square root of 3 over 2 F sub 2 equals 0. let's solve for f sub 2. So I'm going to have, did I solve for, no, let's solve for f sub 1. So I've got the square root of 2 over 2 equals the square root of 3 over 2f sub 2, because we're subtracting, we're going to add. This is f sub 1 multiplied by the reciprocal. I know 4 sub 1 is going to be the square root of 3 over 2 times 2 over the square root of 2 times the 4 sub 2, because I'm multiplying by the reciprocal. My 2's cancel. I now know my 4 sub 1 is going to equal 4 sub 2 square root of 3 over square root of 2. Voila. So now I know what that equals. Let me clean this up and we're going to continue with the solve. Alright, so now I know my 4 sub 1 is going to equal 4 sub 2 times the square root of 3 divided by the square root of 2. And I also have my second equation here, so I'm going to just substitute in and solve. So if I know f sub 1 here, I can just substitute in for this whole thing. And I'm going to get 0 equals 4 sub 2 times the square root of 3 over the square root of 2 times the square root of 2 over 2 plus my 4 sub 2 over 2 minus 1,000. All right, let's kind of clean this up. This cancels, bring the 1,000 over. I've got 1,000 equals 4 sub 2 square root of 3 over 2 plus my 4 sub 2 over 2. I can multiply the whole thing by 2. I'm going to get 2,000 equals 4 sub 2 square root of 3 plus 4 sub 2. I need to solve for 4 sub 2. Factor it out as to GCF. 2,000 equals 4 sub 2, 1 plus the square root of 3. It doesn't matter. It's commutative property. So my 4 sub 2 equals 2,000 over 1 plus the square root of 3. That you just put into the calculator, and I'm going to get my 4 sub 2 is approximately 732.05 newtons. So back to my original diagram, the force on this one, because this is what I define as force cable 2, force 2, is 732.05 newtons. Now, I already know what force of 1 is. I know force of 2. I just plug it in. And once I plug that back in, I'm going to get this to be about 896.6 newtons. So this is 896.6 newtons. And of course, and this is going straight down 1,000 newtons. That's a negative 1,000. That's the forces that's the tension on those cables to hold that 1,000 kilogram item in static. So not terribly bad. I mean, it's a system of equations, having to set up vectors, but it's really not that bad. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.